Greetings and salutations. My name is Andrew Sever, and this is a presentation of the Calvin cycle. Okay, so first things first, what is the Calvin cycle? Well, the Calvin cycle is a process of chemical energy synthesis that is carried out through photosynthesis that takes place in all plants and algae. The process was first discovered by Melvin Calvin in 1950, and therefore the process is named after him. How modest of him. It happens to be the second step in the process of photosynthesis, preceded by the light-capturing reactions that get the ball rolling for energy production. The process occurs in the chloroplasts of the plant cells, specifically in the stroma, the fluid that surrounds the thylakoids in a chloroplast. As mentioned before, the Calvin cycle picks up where the light-dependent reactions leave off. The light-dependent reactions, having just taken in sunlight to produce ATP and NADPH, passes on these products to the Calvin cycle, where they are used to reduce carbon dioxide into sugar. Now obviously I just gave you the Reader's Digest version of the process, so allow me to go into more detail. So in truth, the Calvin cycle itself can be divided up into three main stages: the fixation, reduction, and regeneration phases. The fixation phase is the first step in this process, where carbon dioxide comes into play and reacts with ribulose biphosphate, otherwise known as RUBP, the origin of which I will reveal soon enough. This process is called fixation, as carbon, with a little help from the enzyme rubisco, fixes to the RUBP. This step ensures that the carbon dioxide is able to be used as a source of energy, as once the carbon atoms become fixed to the RUBP, it produces 3-PGA, a 3-carbon organic acid that is used down the line. The next step in this beautiful process is the reduction phase, where the 3-PGA is phosphorylated and reduced. The phosphates used in the phosphorylation step are given by ATP that was produced by the light-dependent reactions from earlier in the process. As for the extra electrons, they are graciously donated from the ever-generous NADPH that is also produced in the earlier light-dependent reactions. The product of all this phosphorylating and reducing is the phosphorylated 3-carbon sugar glyceraldehyde 3-phosphate, otherwise known as G3P. Some of this stuff is sent off to produce other organic molecules such as glucose and other sugars, the main product of this entire process. Finally, the third step would have to be none other than the regeneration phase. In this phase, all of the G3P that wasn't sent off to form the other organic molecules is used to keep the whole cycle going by serving as the substrate for this step. Here, the G3P react with additional ATP to produce more RUBP that ends up going back to the first step, which will inevitably be fixed to more carbon dioxide, creating a never-ending cycle. What a wondrous and fantastic process this is. Thank you for listening and have a great day.